Hello, my name is Mechthild Wörsdörfer. I'm the Director for Sustainability, Technology and Outlooks at the International Energy Agency. A warm welcome from Paris, the headquarters of the IEA. In the middle of the 19th century, Peter Ritter von Rittinger designed and installed the first energy-conserving heat pump system at a salt works in Upper Austria. The system did not generate thermal calories, but rather transferred them from one medium to another. 160 years later, billions of heat pumps induced our daily lives. Most refrigerators, dryers, air conditioners, refrigeration systems, heating systems rely on heat pump technologies. They are also a key enabler of the clean energy transitions. Leading the clean energy transition is the objective and the focus of the International Energy Agency. To do so, we revamped our energy technology perspectives last year and did an in-depth analysis of more than 400 clean energy technologies together with our TCPs, technology collaboration programs, and heat pump technologies are one of the key enabler and the focus of my presentation today. The first thing to keep in mind is that there is not one heat pump. In fact, heat pumps are at various stages of deployment or technology maturity, depending on their design or application. They form a family of technologies whose decarbonization potential spreads across refrigeration, space heating, sanitary hot water provision, drying, washing, and industrial applications. They achieved a dominant design in the field of refrigeration and cooling. Deployment is uneven for building heat application. Market uptake is soaring. In Europe, sales grew by more than 12% per year over the past 5 years. In the United States, the share of heat pumps sales for newly constructed buildings exceeds 40%. For single-family dwelling is now near 50% of new family buildings. Sales of heat pump water heaters have more than tripled since 2010, largely owing to purchasing in China. But fossil fuel and conventional technologies still make up 80% of new heating equipment sales in buildings. The industrial use of heat pumps for process heat generation or drying remains marginal. Even excluding fossil fuel use in co-generation of heat and electricity, direct use of fossil fuel supplied for more than 85% of district heat production worldwide. The most advanced country in terms of heat pump deployment in DHC systems would be Sweden, with nearly 7%. Let me explore a little bit more around 3 key priorities as we see it at the International Energy Agency in our analytical work. The first priority, deployment across all relevant applications. First, we wanted to understand whether heat pumps could generate CO2 emissions immediately, given the strong reliance of power generation on fossil fuels. We quantified the CO2 footprint of heat pumps when the emissions from the power generations are included, and compared them to what if the most efficient condensing gas boiler would emit. The conclusion is very clear. At the exception of a handful of countries in orange, and you can see that on the map, and red, heat pumps already generate significant CO2 emission reduction. 20 to 30% in China, Australia or Poland, which you can see in light green on the map. 50 to 75% in the US, Germany or other Eastern European countries. 85 to 90% in countries where the carbon intensity of electricity is the lowest, such as in Canada, France, or the European Union, Nordic countries. You can play with this interactive map on our web article, Is Cooling the Future of Heating? This is the title of one of our commentary. You can also find on our website. The interface allows you to look at country data in 2019, 2040, 50 or 70, and across different scenarios. You can see, for example, here in 2040, in our stated policy scenario, which is basically the baseline of planned and existing policies, electricity decarbonizes and the map becomes even greener. If you look at our sustainable development scenario, which is aligned with the Paris Agreement objective of well below 2 degrees, electricity fully decarbonizes and heat pumps become a carbon neutral technology almost everywhere. In parallel, many countries are experiencing a strong growth in cooling demand. Each dot here on the map represents a country whose size is proportional to the stock of households' air conditioners in operation. The color represents heat index cooling degrees days, a climate indicator. The global stock of air conditioning will almost quadruple in 30 years, which raises challenges and opportunities. Challenges first. Since policymakers need to address growth in variable, localized electricity demand for air conditioners. While average cooling consumption across the globe is responsible for roughly 15% of peak electricity demand, during extremely hot days, it can be responsible for 50% or more of residential peak demand, as we have seen in some of the big cities like Beijing or New York in recent years. But we also see great opportunities, as it could catalyze innovations and economies of scale to benefit space and water heating applications. Technology progress could be applied to multiple applications. Cooling demand growth could stimulate the adoption of reversible products that can be used for heating purposes. And it is possible to exploit simultaneous heating and cooling generation in vapor compression cycles. Heat pumps need to become the market norm. Several countries already proved that their integration into new buildings is successful, even under very cold conditions. There are market segments where heat pumps are dominant in the EU, in China, Japan, and the US. The integration of heat pumps in existing buildings also ramp up very quickly in our sustainable development scenario, as renovation rates jump from 0 to at most 1% today to more than 2% of the building stock per year, and includes measure of both the building envelope and the replacement of building equipment. This is also the priority of some of the regions, like the EU, who recently launched a renovation wave, and exactly on that purpose. The decarbonization of district energy system is again strongly relying on heat pumps, since their inertia allows to store heat or cold and facilitate the integration of variable renewables. Euroheat and Power estimates that 25 to 30% of the energy transported by the district heating grid could be delivered by heat pumps in Europe. Let me go to our second priority, which is the integration to existing buildings and power system. The deployment of heat pumps is strongly associated to the integration to the existing environment. Therefore, this priority is to unlock their decarbonization potential to foster innovation so that their applicability and services provided are as wide as possible. Heat pumps need to penetrate the renovation market. Existing buildings will represent a significant share of buildings in 2050. About half of today's building stock is likely to be in use in 2050. In developed economies, the average lifetime of a building varies from 30 to 50 years for commercial buildings, to 70 to 100 years for modern residential construction, and 150 years or more for historic buildings. You can see that, for example, here in Paris or in other older cities around the globe. In the developing countries, a majority of buildings have just been built. The average age here of the building stock is between 12 and 15 years only, and for most emerging economies, and 30 to 40 years for more advanced economies. There is therefore a significant business opportunity for heat pumps to adapt their design so that they can be a good fit to the variety of existing buildings integration to multi-family buildings. Compactness for fossil fuel boiler substitution are among key R&D priorities. Holistic renovation are preferable to staggered renovations. Government should focus on promoting single-step, deep energy retrofits encompassing improvements on the building shell alongside replacement of fossil fuel builders. This is crucial to save time, money, and energy. And we see a very good opportunity right now. Coming out of the pandemic, a lot of the governments are putting out recovery or stimulus packages. And this could be an excellent opportunity for governments to invest in the building sector and renovation, which create jobs, which can help the economy and also benefit the clean energy transition and the climate goals. So this could be a golden opportunity for renovation with heat pumps in the future. Another integration priority relates to power systems. Heat pumps could and need to become flexible providers. Flexibility is the key word in our energy markets and electricity markets right now. We analyzed electricity load curves in 2030 in China. We ranked all hours of the year from hours of high net electricity use to hours of low net electricity use. Therefore, from left to right, variable renewable generation tends to increase. Let's see if demand patterns do match or do not match renewable generation. Commercial cooling demand is higher during hours of high variable renewable generation, which is expected given office spaces and IT services are mostly active during the day, with higher cooling needs and higher PV output when it's hot and sunny. The highlighted share of commercial cooling demand on the slide here could typically be met through a direct use of variable renewables, either on-site or off-site, without storage. But residential cooling typically peaks when people come home from work. We notice an increase in cooling needs during hours of high generation, but a much bigger one during the peak load. As much as 150 gigawatt of total power capacity in China in 2030 could be needed to meet residential cooling demand. But such capacity could just as well be avoided through cooling storage systems or flexibility strategies such as pre-cooling. Let me come to the third priority. After deployment and integration, at the service of deployment comes the third priority of our strategic technology enhancement. The strategy chosen to enhance heat pump performance needs to be informed by climate and usage consideration. By 2070, 5 billion people will gain access to cooling, and it's a good thing. People will access more comfort, a number of health issues will be addressed, working conditions will improve, and so on. However, this also means that the efficiency of air conditioners need to be as high as possible to minimize electricity demand growth. Advanced cooling technologies such as evaporative cooling with membrane or solid-state heat pumps are currently at the prototype phase. Yet, they could provide cooling at record-breaking efficiencies under hot and humid conditions, without the use of high global warming potential refrigerants. In fact, without any refrigerants. 1/3 of global population needs both heating and cooling. Historically, heat pumps were most conceived to provide one type of service: heating, cooling, or refrigeration. It is time to make heat pumps multi-service providers. A household could use one piece of equipment used in heating mode during the winter and cooling mode during the summer. In mixed-use areas with concomitant heating and cooling needs, smart thermal grids could make use of the cold produced by heat pumps to cool down offices and the heat generated by the same cycle to heat homes and residential buildings. Let me come to the conclusion. There are different policy recommendations under the 3 priority areas as I described it today. Let me start with deployment. There are near-term measures like incentives, performance-based labels, closing the gap between electricity and natural gas prices. There are more innovation needs in the future to promote testing procedures specific to operating conditions. In terms of integration, we need to ensure reliable use of metering data for demand response and performance monitoring and develop holistic, deep retrofit solutions. Also, for the innovation, we need to support demonstration of compact and integrated heating, cooling, and storage solutions. In terms of enhancement, we need to raise MEPs and promote the use of heat pumps for multiple energy services, as I explained, for heating, cooling, flexibility, renewable integration. For the innovation, we need to use low or no global warming potential refrigerants and advanced cooling solutions. Above all, we need international collaboration. And here at the IEA, we are extremely pleased with our 38 technology collaboration programs. There are more than 8,000 experts around the globe to work together on specific technologies, and we are extremely proud of the technology collaboration program on heating pump technologies. So big thanks for all the efforts done, which helps us in our analytical work, in our work to collaborate more internationally as much as it's needed in the current terms. We see a golden opportunity coming out of the pandemic and having recovery and stimulus packages and the need to focus on net zero and clean energy transition in the long run. Thank you very much for your attention.